Lesson 5. Finding mu and sigma. For a normally distributed variable, you may need to find an unknown mean or standard deviation. Let's do some examples. X follows the normal distribution with a mean of mu and a standard deviation of 3. Given that the probability that x is greater than 20 is equal to 0.20, find mu. We know that the probability that x is greater than 20 is equal to 0.20. When we're trying to find an unknown mean or standard deviation, we first need to code the data so it fits the standard normal distribution. This means that the probability that z is greater than 20 minus mu over 3 is equal to 0.20. You can now either use the inverse normal for 1 minus 0.2, which would be 0.8, or you can use the table in the formula booklet to give you a value of z is equal to 0.8416. And so this means that 0.8416 is equal to 20 minus mu over 3. And solving this gives mu is equal to 17.4752, which we can round to 17.5 to 3SF. Sometimes you may need to find both the mean and the standard deviation. Let's do one more example that shows this. X follows the normal distribution with a mean mu and a standard deviation of sigma. The probability that x is greater than 35 is equal to 0.025, and the probability that x is less than 15 is equal to 0.1469. Find mu and sigma. We again need to code the data. So we know that the probability that z is greater than z1 will be equal to 0.025. And using the inverse normal or the table, you can get z1 is equal to 1.96, and this will correspond for probability that x is greater than 35. We then need the probability that z is less than z2 for this one, which will be equal to 0.1469. We can't use the table in the formula booklet because this isn't a standard value of p, but we can use the inverse normal, which will give us z2 is equal to negative 1.05. And so this means that minus 1.05 is equal to 15 minus mu over sigma. Or in other words, minus 1.05 sigma plus mu is equal to 15. And we can call this equation 1. We can again make something similar for this part, where 1.96 is equal to 35 minus mu over sigma. And so 1.96 sigma plus mu is equal to 35. And we can call this equation 2. Now we need to solve these simultaneously. So we can eliminate mu by doing equation 2 subtract equation 1, which gives us 3.01 sigma is equal to 20. And so sigma will be equal to 6.6445 and so on. And we can sub this back into equation 2 to give us mu is equal to 35 minus 1.96 times by 6.6445 and so on, which gives us about 21.976. And so therefore we can say that the standard deviation sigma is equal to 6.64, and mu, the mean, is equal to 22.0, both to 3SF. And that is about it.